Hola, Mr. Sutton here. I've got the Pre-Cal Honors 3-2 Part 2 homework solutions on multiplying and dividing rational expressions. To divide these fractions, let me multiply by the reciprocal. So I'll do x to the 13th over 27 times 6 over x cubed. So same, change, and then flip. And since these are in different fractions, but they're multiplying the fractions, I am allowed to cross-cancel or cross-reduce things. I should probably do that before I multiply stuff together. So let's see here. The 27 and the 6 can interact. Those are both reducible by 3. So the 6 becomes a 2, and then 27 divided by 3 is 9. X to the 13th over x cubed, I can reduce those. Subtracting the exponents, that gives me x to the 10 up here, and then just an invisible 1 down there. Multiplying what's left, we have 2x to the 10th in the numerator, and all that's left in the denominator is that 9. For this one, I've got division of fractions, so I need to use same, change, flip. So keep the same fraction the same, change this to multiplying, and flip to get the reciprocal, 18 over x to the 11. Now I'm allowed to cross-cancel as needed because I'm multiplying. 10 and 18 can reduce. Those are both divisible by 2, so this 18 can become a 9, and then the 10 is going to be a 5. Now the x to the 6 and x to the 11th can also get reduced. Using my exponent rules and subtracting those, that's going to leave me with x to the 5th downstairs, and I just have an invisible 1 back up here. Multiplying straight across now with the leftovers, we have 1 times 9, so that's 9 in the numerator. And in the denominator, I've got a 5 times an x to the 5th, so 5x to the 5th. To divide these rational expressions, I have to first multiply by the reciprocal of the second fraction. So same, change, flip. Keep the same fraction the same. Change this to multiplication. Flip this next one to 5x minus 10 over 21. And now I can multiply. But before I multiply, I actually want to factor and cancel whatever I can, just so I have less of a mess to deal with later. So the 14 and the 21 are good to go. But in the lower left, we can take an x out of that expression, leaving us with x minus 2. And in the upper right, we can take a 5 out of that. So that's going to be an x minus 2 in there as well. So the 14 and the 21, we can cross-reduce those since I am multiplying. And that leaves me with a 2 up here if I divide by 7, and a 3 down here. And I can also actually cancel out these x minus 2s. I can cross-cancel those. So what's left in the numerator? Well, we have a 2 times a 5. That's 10, yep. And in the denominator, we have an x times 3, so 3x. So then 10 over 3x. For this problem, I have division that I'm trying to simplify. Before I do anything else, I need to turn this into multiplication by multiplying by the reciprocal. So I keep the first fraction the same, change division to multiplication, and flip the second fraction, so that 8x minus 32 is now in the denominator, and this other thing is up top. Everything else is the same, though, in the first fraction. Now, before I actually multiply, I need to factor and cancel and reduce as much as possible here, or else I'm going to have a nightmare on my hands. So in the upper left, we can take out an x, leaving me with an x minus 4. In the lower left, I need factors of 30 that add up to 13. 1 and 30 doesn't work, neither does 2 and 15. 3 and 10 works, because 3 plus 10 is 13. So I have x plus 3, x plus 10. And now in the upper right, I need factors of negative 50 that add up to 5. So let's see, 1 and 50, 2 and 25, none of this is working. How about 5 and 10? Well, if I had negative 5 and positive 10, that would work. So x minus 5, x plus 10. And now down in the lower right, I can take an 8 out. That leaves me with an x minus 4. So what can I cancel at this point? Well, I see an x minus 4 here and also down here. I am allowed to cross-cancel because I am multiplying, so I can cross off those x minus 4s. And the x plus 10s can also get cross-canceled. And that's about it looks like. So in the numerator, we now have an x times x minus 5. And in the denominator, we have an 8 times x plus 3. And that's as good as it's going to get. The very first thing I'm going to do to simplify this division is to take multiplication instead. So I'm going to do same, change, flip on this. Keep the first fraction the same. change this to multiplying, flip the second fraction so that that x squared plus 3x minus 4 is now the numerator, and 10x minus 10 is our denominator. And before I even multiply, I'm actually going to factor and cancel whatever I can. Otherwise, this is going to be a huge mess. So in the upper left here, I can take out an x, leaving me with an x plus 9. In the lower left, I need factors of negative 54 that add up to 3. Well, let's see, we got 1 and 54 doesn't work, 2 and 27 doesn't work, 3 and 18, no way, and then 4 doesn't even go into 50. 6 and 9, well, that might work if I had negative 6 and positive 9. So let's do x minus 6 and x plus 9. All right, well, there's something I can cancel in a minute. Moving over to the upper right, factors of negative 4 that add up to 3. Not a lot of options here. We have 1 and 4, that's going to work. If I have negative 1 and positive 4, so x minus 1, x plus 4 for that. And then in the lower right, this one's not so bad. I just take a 10 out of that. That leaves me with an x minus 1. So it looks like I can cancel out these x plus 9s for sure, and also these x minus 1s. And I don't think there's anything else. So we have an x, parentheses x plus 4 in the numerator, and in the denominator, I have a 10 times x minus 6. To deal with this division of fractions, I'm going to turn it into multiplication, specifically by multiplying by the reciprocal of this second fraction. So first fraction stays the same. This is now multiplying, and I'm multiplying by 4x plus 20 over 13, so reciprocal, same change flip. And it looks like, let's see, I can factor this a little bit. That's probably a good move before I try multiplying. So the lower left, 39 and 13, those will stay the same for now. But in the lower left, I can take an x out of that. That leaves me with an x plus 5. And in the upper right, we can take a 4 out of those, leaving me with an x plus 5 up there. 39 and 13, I can cross-reduce those because we are multiplying the fractions. So those reduce to a 3 in the numerator and an invisible 1 down here. I can also cross-cancel these x plus 5s. Again, I'm allowed to cross-cancel since I am multiplying the fractions. So now what's left over? In the numerator, we have a 3 times the 4 that was already there. That's 12. And in the denominator, all that there is that x.